Okay, so today I am going to explain about this Variance Principle. This is the statement, okay, the moment of a force about an axis is equal to the sum of its component about same axis. Okay, what is the meaning of this statement? Okay, so now I am considering F1, F2, F3, F4. Okay, so number of forces acting on a given system at your point. Okay, so at your point. So what is the meaning of movement? Force into perpendicular distance. Then F1 into X plus. Now I am taking moments of the F1, F2, F3 forces. F2 X plus F3 X, okay, so up to Fn Xn equal to R into X. What is the meaning of this statement? Very simple. The sum of all the components of a movement is equal to the resultant of the movement. So that is the statement of the Variance Principle. Clear? Okay, the sum of all the moments of a force in a given system at a point is equal to their resultant moment, that is known as Variance Principle. Okay, so we have some derivation is there. Okay, so please see the derivation. Now I am taking two forces P and Q. Now I am taking two forces P and Q. So these two forces acting at a point O. Then see here. Now I am taking two forces. Okay. So this force is P and this force is Q. These two forces acting at point O. The resultant of these force is R. Okay, it is represented by capital R. Okay, so P and Q are the two forces, okay, acting at a point O, and the resultant force is R. Okay, so please take the perpendicular distances from P and Q and R. Okay, so why we are taking perpendicular distance? Okay, what is the meaning of Variance Principle? The sum of all the moments of a components. In this case, now I am taking two components P and Q. Moment means force into perpendicular distance. That's why I drawn perpendicular distance from point A. Now I am taking, this is the point A. This is the point is A. Okay, so please draw the perpendicular distance from P and R and Q. See, okay, so this is the, now I am taking this one is the R. The perpendicular distance of P is R. Okay, next one is okay, so drawn one perpendicular distance from R, capital R. Okay, now I am taking small r is the perpendicular distance of force F. Okay, so next one is, now I drawn one vertical line, that means perpendicular line from force Q. Okay, so please consider this is the R2. This is the R2. Okay, next one is the angle between, so these two lines is, now I am taking alpha 1 horizontal line to the force P. Okay, next now I am taking is the alpha, angle alpha is the alpha. Okay, so between R and horizontal line. Next, now I am taking is the alpha 2 or theta 2, whatever may be. So instead of alpha 1, so you can substitute a theta also, no problem. Then theta 1, theta 2 and theta, or alpha 1, alpha and alpha 2 as your wish. Okay, so this is the alpha 1, next this is the alpha, this is the alpha 2. Okay, so the next one is, see here, now I am taking this one also alpha 1, this one also alpha 1. Okay, so the angle between R1, perpendicular distance R1 and AO is the alpha 1. Next, okay, the angle between R and AO is the alpha. Okay, next one is the angle between R2 and AO is the alpha 2. Okay, so these are the angles. Okay, but in this case you need to calculate the moment of the components. So we have two components, one resultant force. P and Q are the two components. Okay, now I am taking, so moment of the force P, moment of the force P. Okay, so moment of the force P. Okay, so moment means force into perpendicular distance. This is the force is P, distance is the R1, force into distance. Okay, so this force and perpendicular distance, this force into distance is the R1. Similarly for Q, okay, so force Q. Next, this force is Q, distance is R2, force into distance is the moment. Okay, now I am taking Q into R2, for resultant force. Okay, so for resultant force, R into small r. So R, this is the force and perpendicular distance is the R. Okay, the moment of the force P is P into R1. Okay, the moment of the force Q is Q into R2. The moment of the resultant equal to moment of resultant equal to R into capital R. So P is the force, R1 is the distance. Okay, Q is the force, R2 is the distance, perpendicular distance. R is the force, capital R is the force, small r is the distance. Okay, so moment completed. Okay, so now I am taking so P into, then R1 equal how much? This R1, perpendicular distance, R1 equal how much? So please consider this is the OA into cos alpha 1. Okay, see here, now I am taking this O. Okay, so this is the point is A, this is the point is O, this one is the R1, this one is the R1. So angle is alpha. Okay, so angle opposite is the sine, adjacent is the cos. So but how to calculate the, so this length, complete length. Okay, so R1. Okay, so this OA into cos alpha 1. Okay, so OA into cos alpha 1. Okay, then R1 equal to OA into cos alpha 1. Similarly Q into OA into, instead of alpha 1, so please consider alpha 2. Okay, so why we are taking alpha 2? The angle between, so OA and R2 equal how much? Alpha 2. Okay, so similarly for resultant force, capital R into OA cos alpha. Okay, next now I am taking OA into P cos alpha 1. So please consider. Okay, so OA is the separate. Okay, so please multiply with P into cos alpha 1. Okay, then OA into Q cos alpha 2. Similarly, then OA into R cos alpha. Okay. Then now consider P cos alpha 1 is the Px. OA into Px. Next, OA into Qx. Please consider this is a Q cos alpha 2 equal to Qx. So finally OA into R cos alpha is the Rx. R cos alpha is the Rx. Okay. So what is the meaning of Variance principle? Variance principle, the summation of all the moments of a component. Okay. So we have three components. This is the number 1. This is the number 2. This one is the resultant, moment of a resultant. Okay, so please take according to this principle, the summation of two components. Okay, so two components means how much? The summation of two components. Now I am taking her here. Okay, the summation of two components means, okay, so OA into Px, this is the moment of the force P. Next, the moment of force Q is the Qx, that equal to the resultant of the moment equal to Rx into OA. Okay, so then OA, the remaining terms are OA is the common, Px plus Qx equal to then Rx into OA. Okay, so the next remaining terms are Px plus Qx equal to then Rx. Okay, so this is the final statement of Variance principle. Statement or final formula of Variance principle. Okay, but Px, where is the Px in diagram? See here, from here to here is Px. This position is Px. Okay, the next one is, this one is the Rx, this one is the Rx, then Q, this one is the Qx. Okay, so Px, Qx and Rx. Okay, so this is the statement and so derivation of Variance principle. This is a very important. Clear? Next one is parallel forces. Parallel forces and types of parallel forces. Okay, and types of parallel forces. Okay, what is the meaning of parallel forces? Definition. So this one also very important. Okay, the forces, see here, the forces whose line of action parallel and not in a straight line, this is known as parallel forces. Okay, so what is the definition of parallel forces? The forces whose line of action parallel and not in the same straight line, that is known as parallel forces. Okay, see here, now I am taking 2 pens, 1 minute. So now I am taking 2 pens. Okay, see here. So this one is, now I am taking 2 pens. So this is the one force, this one is the another force. These forces act, or whose line of action, so these two are parallel to each other but not in a straight line, that is known as parallel forces. Okay, so these forces acting parallel to each other. Okay, so these forces acting parallel to each other. Clear? Next, types of, now I drawn, this is the force F1 and this one also force F1 or F2. These forces acting parallel to each other. Okay, the next one is types of parallel forces. Types of parallel forces. Okay, so in this case divided into two types. First one is like parallel forces, second one is unlike parallel forces. What is the first one? Like parallel forces. Like parallel forces. Second one is unlike parallel forces. Okay, like and unlike. So what is the meaning of like parallel forces? Okay, see here, so these forces acting parallel to each other. Okay, but the direction of these two forces same, that is known as like parallel forces. Like parallel forces. Okay, unlike parallel forces means, so these, in case of, now I am taking two forces F1 and F2, these forces acting parallel to each other but acting opposite direction. This is the F1, see here, now I am taking, this is the F2. So these two forces acting opposite direction but parallel to each other. These forces, so these type of forces is known as unlike parallel forces. Okay, now I am taking two forces F1 and F2. So these two are parallel to each other and the direction of these two forces same, that is known as like. Next one is unlike parallel forces. Unlike parallel forces means F1 and F2 acting opposite direction but parallel to each other. So this is known as like and unlike parallel forces. Okay, so now I am taking some different conditions. See here, different conditions. Next one is the resultant of two like parallel forces and the resultant of two unlike parallel forces. Okay, so please see the diagrams. How to calculate the resultant of two like and unlike parallel forces. Now I am taking one horizontal line. Okay, so and consider F1 and F2 forces. These two forces acting on the line. Okay, the resultant of these forces is R. These forces is R. Okay, now I am taking the resultant force is equal to the F1 plus F2. Okay, so because of, so these two forces F1 and F2 are parallel to each other and acting same direction. So same direction means like parallel forces. Okay, so the resultant of like parallel forces is F1 and F1 plus F2 equal to R. Next, the resultant of unlike parallel forces. Unlike parallel forces F1, F2. These forces acting opposite directions, but so these two are parallel to each other. Okay, the resultant of these two forces is R. Okay, what is the formula of R? Then R equal to F1 minus F2. This is the resultant of unlike parallel forces. See here, F1 and F2. These forces acting parallel to each other but in opposite direction. This is the force is F1, this is the force is F2. Okay, so these two forces acting opposite direction means unlike parallel forces. Okay, so the resultant of force is F1 minus F2. Why we are considering the F1 is the first? Because now I now I am taking is the F1 is greater than F2. F1 is greater than F2. So that's why I taken F1 minus F2. Clear? So these two are resultant of the like and unlike parallel forces. Okay, so this Varginan's principle and these parallel forces definition and types of parallel force definitions. Okay, and problems on parallel forces. Okay, like or unlike parallel forces. Very important for semester examination.